Good afternoon, my YouTube viewers. It is Crystal here. I'm just here because I wanted to do a code review. Um, Last week I did a code review on Cackle's Playground Series Episode 2, and now I'm going to do a code review on Cackle's Playground Series Season 3 Episode 2. And basically, last week it was the first episode of season 3, and then this week it's the second episode of season 3. And then what they're going to do for the month of January is they're going to have 4 competitions for the month of January. So this is the second competition, and it's a tabular classification with a stroke prediction data set. So I went ahead and I entered the competition and I submitted it. So you can see that my score was 86%. If you look on the leaderboard of the score, which I think that's where we are now, you see that I am 51, number 51. So that's not too bad. So I was 86% and the highest score was 87%. So that's not too bad. So now what I'm going to do is I only submitted 1 entry, and the reason why is because I'm very busy. So we're just going to go ahead and go over the code review of this 1 entry that I submitted. So we're over here in the code, so you can see the code. I've had 9 views so far. Here's my notebook. Here's the problem statement for Season 3, Episode 2. The data set for this competition, both train and test, was generated from a deep learning model on the stroke prediction data set. Feature distributions are close to, but not exactly the same as the original. Feel free to use the original data set as part of this competition, both to explore differences as well as to see whether incorporating the original and training improves model performance. Well, I didn't look at the original, I just used the one that they gave us. So the first thing that you want to do is you want to open up a Jupyter notebook, and I opened up my Jupyter notebook in Kaggle, which is a free online Jupyter notebook. And then so I imported the libraries that I was going to use. So I was going to import NumPy as NP, which is a numerical Python library. I imported Pandas as PD, which is the panel data library. Importing OS, which is operating system. Importing Matplotlib PyPlot as PLT, which is a graphic system. And importing CPLEARN as SNS. And I entered this competition in an hour. I did it all before I had to go to work. So I didn't think I did too bad a job, since I had to sort of like rush to do it. Then what we're going to do is we're going to load the files. So we're going to use OS to go into the directory and load up all of the files in the directory, which is train, test, and sample submission. And then we're going to use Pandas to read the files and convert them to data frames. So you've got train, which is 12 columns of data, 15,304 rows by 12 columns. And so here it'll tell you if it's a stroke. Here's the test data set. It's 10,204 rows by 10 columns. And here is the submit. So you can see here that it was a binary classification, but what they want you to submit is actually a fraction. or a float. And so what I thought, well, how am I going to do this? Because this is a binary classification and they want a fraction of a number. And so I decided, well, the best thing to do is to do a predict proba, because predict proba tells you the chances that you get of a 0 and the chances that you get of a 1. So that's what I decided to do. I decided to use predict proba. So I wanted to analyze the train and the test set. So fortunately, I didn't have any missing values in the train or the test set. So that means that I didn't have to impute any missing values or delete any missing values or delete any columns or anything like that. So now what we're going to do is we're going to analyze the stroke, which is your target. So you can see most of the values were 0, but some of them were 1. And you can see that this is an imbalance. It's an imbalance class. So not only are we not predicting 1s and 0s, we're also predicting on an imbalance class. And there's lots of ways that you can deal with an imbalance class, but what I will say about sklearn is some of their estimators that they use had the capacity to use balance. So like I used Logistic Regression, and when you go over here to Logistic Regression, it says class weight, and so you set your class weight to balance. And then when you set your class weight to balance, then that's a way to deal with imbalances. And there's lots of ways that you can deal with class imbalances. It's not just one way, but that's what I decided to do. So we wanted to combine our train and our test. So your target equals train and the stroke column. And then now the combi equals train dot drop stroke axis equals 1 dot append test. Here's your combi. So you got 11 columns by 25,508 rows. So now what we want to do is we want to check for unique values. So for call in combi, if combi call dot dtype equals 0, that's an O, that's an object. Print call combi call dot unique. So the columns that had objects or strings were gender, ever married, work type, residence type, smoking status, and then we put the unique values in there. So male, female, other for gender, yes, no for ever married, private, self-employed, government job, children, never worked for work type, urban and rural for residence type, never smoked, formerly smoked, unknown, smokes for smoking status. So obviously they thought smoking is a really big factor and whether a person has a stroke or not. So now what we're going to do is we're going to ordinal encode all of the columns that are objects. And the reason for that is because the computer can't really make predictions on objects. So that way you have to convert the object to a number. So there's lots of ways that you can do that. One way that you can do it is just to use the replace function. And so if I had only 1 or 2 columns of data that were objects, I may very well have used the replace function. But since I had several columns of data that were objects, I decided that I would just use sklearn's ordinal encoder. So for call in combi, if combicol.dtype equals O, combicol equals enc.fit transform, combicol.values reshape -1, copy. So that code there enables you to orderly encode every column that is an object or a string. So you can see right there, like ever married, work type, smoking status. You can see right there. Gender. Now what I decided to do was to create a heat map. So core equals combi.core and S heat map core. So what the core means is the core is the correlation. And so what you can see here is the dark colors are a low correlation and the light colors are a high correlation. But you didn't have anything that was really high. The highest color that you had was like a 0.6, 0.7, 0.8, and the rest of them were low correlations. But I checked the correlation here, and so if you want to know the numeric value for the correlation, you can always check the correlation here, but you can always see that they had a low correlation. So I decided that I was going to remove columns with a high correlation, so I inserted code that will help me remove columns with a high correlation. But note there were no columns that had a high correlation, so no columns were reduced. Now what we're going to do is we're going to normalize the data, and what happens when you normalize the data is you're going to convert it to a value between 0 and 1. And the reason why is because the computer does a better job of making predictions on data that is closely related, so in closely dimensioned. So that's why we did that. And you can see here that we inserted the code combi equals combi minus combi.n over combi.max minus combi.min, and you can see that that converted all the values, all the cells, to a value between 0 and 1. Now after we've done that, what we want to do is we want to define our x and our y variables. So your y variable is your dependent variable, and that is your target. Your x and your x test are your independent variables. And so x is compi, and it's going to be the length is 0 to the length of train. And x test is compi. It's going to be the length of train to all the way to the end. And now what we're going to do is we're going to use train test split to split the x and our y data set into training and validation sets. So you can see we split it into training and validation sets. And we're going to select our model, and in this particular instance we use logistic regression. And then when we use logistic regression, we set the class weight to balanced. And what that does is that deals with the class imbalance. So we had a 78% on that. We predicted on the validation set, and we used predict, and we had a 79% when we predicted on the validation set, but we also used the predict proba. So you can see predict proba, and it was column 1, and you have to remember that in Python the first column is 0 and the second column is 1. So we're looking at column number 1 for the predict proba. We put a confusion matrix on that. So we had 11 5 5 zeros, that's a true positive, and 308 ones, which was a false negative. We had 11 zeros, which was a false positive, and 57 ones, which was a true negative. And now we're going to predict on the test set. And as you remember, I did this when I was going to work, And so I couldn't put all the bells and whistles, like I couldn't compare the actual values to the predicted values, but that would not have worked anyway, because the actual values were either a 1 and a 0, and then we had to use predict proba to convert it to a probability. So that's another thing I can work on, is probabilities. But you can see the test set. We have our predict proba on the test set, and then so we prepare our submission. So submit.stroke equals y test proba, and it's column number 1. Submit to CSV, submission CSV, index equals false, so we convert it to a CSV file. Submission equals PD read CSV submission, so we read it and then we print it out. So you can see that we have our ID numbers and we have our predict proba, and that's the probability that it's going to be a 1, or they're going to have a stroke. And so that's what I did. Now, if I had wanted to, I could try to improve my score by using a gradient boosting classifier or a random forest, because that might improve my score. But at the moment, I'm really busy working on some other things, so I'm not going to work to improve the score. I'm just going to make a blog post on what I've done, and maybe whenever I have more time I can improve the score. But if you want to improve the score, you might want to try random forest or gradient boosting classifier, and that might help you improve the score if you want to try to improve on my score. So I think that concludes this code review. I've covered everything in the code review. I explained to you what I did and why I did it, and I explained to you what you could do to improve the score if you wanted to. So I'm going to go ahead and conclude this code review. So I would like to thank all of my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. And thank you so much for watching my video. I look forward to making more videos for you in the future.